Hi YouTube, it's Sidnaf. As you may know, I'm working on a calculator right now, and as such, I need to have numbers be displayed on a 7-segment display for users from all backgrounds to be able to read. And what this calls for is for the binary numbers that I use in my everyday machines, like adders, subtractors, etc., to be put into binary coded decimal and onto a 7-segment display. This is done with an algorithm called Dabble, which is a shift and add algorithm that left shifts a number from binary into a bunch of binary coded decimal like segments for the 7-segment display, and every time each specific segment is greater than 4, you'll add 3 to it and then continue shifting. This sounds weird, but let me just show you an example. So numbers will be inputted serially, like this. So if I had 1, I would say 1, and since this is 1 bit long, it would shift it once. And then you can go over here and see I am not lying to you, and we would get a display of 1. On the actual calculator, I've already implemented this. All the numbers will be right justified, so you'll never have leading zeros just because I think that looks awkward. You know. So now if I want to input 2, it's still just 1, but it's 1 0, so it would shift 2 times because that's how many bits it is. Now if I wanted to do 10, that's 1 0 1 0, so that'd be 1, then we already did the 0, then we did the 1, shift it again, and then we'll click this off, and then the 0, and then we'll shift it again. So as you can see, I got 10. So now let me think. If I do another 1, I'll get 1 0 1 0 1, which will be 21. So if I shift it, with that being active, I'll have inputted 1 0 1 0 1, which will have given me 21 on the 7-segment display. Now this sounds very tedious, and don't get me wrong, it is. But the thing is, this is a sequential machine, meaning that it goes in a sequence of a number of iterations. This is in contrast to combinational logic, which would be, I would input the numbers in parallel, and they would go through a whole bunch of specific processors, a whole bunch of things similar to this, but that, even though it does do it without a clock and without thinking how many times I have to click it, those become unwieldy extremely quickly. Those would be like 15 times the size of this in terms of length, because they'd be using very similar adder designs, because this doesn't actually use a comparator. Since it's only 4 bits, I can logically think, oh, anything greater than 4 will definitely be 8, anything with the 8 splice active will be greater than 4, and if the 4 splice is active, if 2 or 1 splice are active, then it's greater than 4. So that's just a bit of Boolean logic I used. Yeah. So obviously sequential in this case was significantly better for me. I don't think for the user input I'll do sequential. I think I'll have a smaller combinational input, since the smallest, I mean the largest number you can input is 9999, so that's half the size of this. So I think in that case I could get away with combinational, but when it comes to the actual outputs of all the calculations, I'll be doing sequential. And not only that, but because I want to have the user be able to see the number they're inputting in real time, the sequential will be kind of awkward. Just combinational. You know, there's a time and place for everything, and that's definitely time for combinational. If you have any questions for me, you can just let me know in the comments, and thank you for watching.